Today we're going to go over the final unit review for trigonometry. We start with a Ferris wheel modeling problem that says the function displayed models Jessica's height in feet as a function of time in seconds as she rides a Ferris wheel. So for each of the questions, it asks to click on the part of the equation that represents the radius of the Ferris wheel. Well, this goes back to the beginning of the unit. And off to the side here, I'm going to remind you how we discussed the height of a rider using the sine function as a model. In general, we would say that the radius of the Ferris wheel would determine the amplitude of the sine function, so radius times sine of the angular speed times t plus the center height of the Ferris wheel. So in a real-world modeling context, we don't call them amplitude, frequency, and midline because these values actually mean something now. So for number one, it says click on the part of the equation that represents the radius. You just had to know that the a value, right, which we normally call this the a value of a periodic function, is 25. That represents the radius. Number two wants us to click on the part of the equation that represents the center height. Well, that's over here. That's our c value from the general function. And then it has us click on the frequency, which we call speed. So as long as you clicked on the 3 there, which is our b value. And then number 4 wanted us to figure out what's the height at the top of the Ferris wheel. Well, recall if our center height, I'll draw a Ferris wheel over here to the side. Right, if our center height, if the height from the center to the ground is 40 feet, and then the radius of the Ferris wheel is 25 feet, the answer to this question would be 40 plus 25, which would be 65 feet. Number 5 wants us to do some modeling here. It says a Ferris wheel has a diameter of 60 feet. Well, right away, just as a quick note, radius is always half of diameter. So this would be 60 feet over 2, which is 30 feet. The bottom of the Ferris wheel is 10 feet off the ground. The rider is at the maximum height of 70 feet after pi seconds. Write an equation that models this situation. Okay, so it says the maximum height is 70, so from here to the ground is 70. It said the bottom of the Ferris wheel to the ground is 10. And the diameter is 60, so half and half, 30, 30. So first off, just using my diagram, I can already speak to the center height. The center height would be the distance from here in my little green writing here. At the center, you're 10 feet from the bottom plus 30 feet radius, so this would be 40 feet. So from the modeling questions before, that would be our plus c value, which would be here. Okay, and if you recall, I'll just scoot back real quick. H of t equals the radius times sine of the angular speed times t plus the center height. So radius is our a value, so radius would be 30. In general, we use sine. You could use cosine as well, but just to go along with the modeling we've done before, we usually represent sine as a height because it's the y-coordinate. And then it says the last blank is the frequency. This last part's a little tricky. Let me draw a little graph to help you visualize this. So let's say your height of a rider graph looks something like this. Now, what I tell you is that at its maximum height, which would be here, that's at pi seconds. So that's the x value, pi. Well, if you think about it, we've talked about how the period, a full period of the sine function, you can think of it as 4 pieces or 4 slices because you start on the midline and the first fourth is going to the maximum and then you go to the mid, then you go down to the min, then you go back to the mid. So if you just keep adding pi seconds, you can look at your full period in terms of these little pieces. If you reach your maximum at pi seconds, then you're going to reach the mid in the same amount of time, your min in the same amount of time after that, and then finally back to your mid after the same amount of time after that. So your period is 4 pi seconds. And to find frequency, your b value, it's 2 pi over your period, and our period is 4 pi. And 2 pi divided by 4 pi simplifies to 1/2. So you could have said 0.5 or 1/2. And if you put that all together, that should be the function, 30 times sine of 1/2 t plus 40. Okay, blood pressure model. The average person's blood pressure is modeled by the function f of t equals 20 sine of 2.2 pi t plus 100, where f of t represents the blood pressure at time t measured in minutes. So we're just going to use this function here to find a couple things here. It says, give the blood pressure of a person according to this model after 15 minutes. Well, I'm going to hop on over to Desmos, and I'm going to type in this expression as is. Okay, 20 sine, and the parentheses is already there for me, 2.2 pi, they say it's t, and then plus 100. So I just want to illustrate something. When you type in a function that has a variable like t, Desmos does its best to understand what you're trying to ask, but unfortunately it doesn't recognize t as an independent variable. And either way, we're actually not asking it to graph it at this moment. We're actually just asking to figure out what's going on after 15 minutes, which is t measured in minutes. So where this t is, I'm just going to replace that with times, and they wanted to know what's happening at 15 minutes. So according to me just plugging all the correct information into the function, if you replace t with 15, you get exactly 100. So that would be the answer, 100. Okay, the next question asks, what is the maximum blood pressure of a person according to this model? All right, now this model might look really confusing because we've maybe not talked much about a lot of applications of sine models. Let's try to make some sense of this. Hopefully you're familiar with the idea of this plus 100 being our c value, which means that's our midline. So let's say your midline's at y equals 100. Like let's say this is 100. Well, sine has a look like the following, right? Starts at the midline, goes to the max, mid, min, back to the mid. Now, this first point up above the midline, this one right here, this is the max. And the point that at the bottom here is called the min. And you might ask yourself, well, how am I supposed to know the max and the min? Well, that's based off of the a value called our amplitude. So that would tell you the distance between the midline and those points. So since it goes up 20 and down 20, we can easily say that the maximum would be 100 plus 20, and the minimum would be 100 minus 20. So 7 and 8 ask actually these two questions. So the maximum would be 120. So according to this model, the maximum blood pressure you'd have would be 120 over this interval, and the minimum would be 80. Okay, the water levels at a beach are modeled by the function h of t equals 3.4 sine of pi over 6 times the quantity of t minus 1 plus 2.1, where t represents the number of hours since midnight for any given day. Height is assumed to be in feet. You do not need to give units in your answers. Number 9, what will be the height of the water at 1 a.m.? And I give you a little hint there, 1 hour past midnight. So according to this crazy looking function here, if you just plug in how many hours have passed since midnight, it will tell you the water level, right? How high the tides are at a certain beach. So very similar to the last one, I'm going to try to do my best to type all this into Desmos so I can use it as a function expression to just plug in the t they're asking me and just see what happens. I'm just going to go ahead and answer the first question, just 1 hour past midnight. So that means t equals 1. So I'm just going to replace x, t, the independent variable, with 1. And it should just respond back with the answer here. 2.1 is the answer. So the water level would be 2.1 according to me just typing out the function expression and plugging in t equals 1. So 2.1. And obviously that means feet, but you don't have to give the unit. All right, what would be the height of the water at 2 p.m.? Okay, so think about this. We're trying to figure out what t equals going from 12 a.m. to 2 p.m. To help you make sense of this, if you're not very good at time, let me break this up into easier chunks. If I said how many hours pass from 12 a.m. to 12 p.m., right? Midnight to noon, that is 12 hours, right? And then you just add another 2 hours to get to 2 p.m. So I don't know if anyone has trouble thinking like this, but from 12 a.m. to 2 p.m., it's 2 plus 12 hours. So we're going to plug in t equals 14 because 2 p.m. is 14 hours past midnight. So I'm just going to go back to Desmos, and where I plugged in 1 minus 1, right, for t, the 1, I'm just going to type 14. So according to the model, at 14 hours past midnight, the water level is now 3.8 feet. Now, number 11 says, after how many hours past midnight will the tides reach their maximum height? Answer must be before noon. So to answer this question, you just have to think of this as a graph, right? Like this graph of sine should have midpoint or midline points, maximum points, minimum points. The easiest approach to this would be if I go back to Desmos and I go back and replace 14 with my independent variable, right? Anything with an independent variable, Desmos will try to graph. And what you actually have here is a representation of what the model's showing us. So it's showing us, right? Remember how we did 1 hour past? It was 2.1, right? So at 1 hour past midnight, it's 2.1. We can even go all the way to 14. At 14, we got an answer. Let's see here. 3.8, right? It gives the same information. And what we can do is just follow the graph to find the maximums. So the maximum value reached is 5.5, and the answer is it took 4 hours to do that. So it says, after how many hours past midnight will the tides reach their maximum height? Answer must be before noon. So the answer I'm choosing is before noon, because if I go to the other maximum, it's at 16 hours past, that would be past noon. So 4 hours would be 5.5, the maximum, so 4 hours. What is the lowest water level according to the model? Well, we could go back to the graph, but just to kind of go off of the last model, remember that your minimum is always your midline minus your amplitude. And this will equal our minimum. So the midline was 2.1, and the amplitude is the value in front of the sine equation, which is 3.4. So 2.1 minus 3.4 is negative 1.3. And negative 1.3 might be a strange answer, but think about water levels. Sea level means you're at 0 feet, right? If you're right at the beach, that's 0 feet sea level. But this can go below the beach, which means it's below sea level. So this is 1.3 feet below sea level. 13, what is the highest water level according to the model? We'll just do the same thing we did in the previous one, but now we're going to add, so it'll be the midline. So in this case, we're going to do 2.1 plus 3.4, which is 5.5. So the highest this water will rise will be 5.5 feet. And lastly here, Sarah's trying to write the trigonometric function model for some temperature data. She knows that her model will begin with a maximum temperature of 96 degrees. That is the highest at noon, which will be x equals 0. She also knows that the model will reach a minimum temperature of 68 degrees at midnight. Complete the model below. Okay, well, there's some information given to you that you can choose from. We know that the maximum, let's just write down some information here. Our maximum is 96 degrees, and our minimum is 68. Well, to find the midline value, recall that the midline has to rest right in between 96 and 68. So we have to take the average. So 96 plus 68. And then if you divide that by 2, (82). So 82 degrees. So I know my midline value is 82, and that's our C value, right? So remember, this is based off of this idea. So A sine, let's say, of bx plus c. We just found that our C value is 82. That goes here. We can also find the amplitude, because the amplitude is the distance from your max to your midline, or the distance from here to here would be your amplitude. So to find the distance, just subtract. So our amplitude, we can just go ahead and do 96 minus 82, 14. So what that means is from the midline, if you go up 14 degrees, you hit the max, and if you go down 14 degrees, you hit the minimum. So 14 is our amplitude, A, and we'll see if we need to make that negative for some reason, but let's read on here. So we know that the model will begin with a maximum temperature. Okay, so right away, if we're beginning with a maximum temperature, that can't be a sine graph. And just to remind you, hop back over here. Just to refresh your memories, if I type sine of x, what you have to recall is that sine is a function that likes to start right on the midline, and it should travel up to the maximum, back to the mid, down to the minimum, then back to the mid. So that's the 5 main points of one period of sine. Now, if we go ahead and do cosine, it has the same values, but they behave a little differently. Cosine starts at the maximum, goes down to the goes down to the midline, then the minimum, back to the midline, then to the maximum. So since our function starts at the maximum, it's going to be a cosine function. So ours is going to be cosine. So not sine, cosine. Lastly, we just have to find this thing called frequency, which is based on the period. So let's see here. It says this model will reach the minimum temperature at midnight, but my model starts at noon. So to go from maximum to minimum, it takes 12 hours. Think with me for a moment here. If I have my model and the graph looks something like this, right, that's cosine, max to max. So I'm going from max to min to max. If I know that from max to minimum, it takes 12 hours, because noon to midnight is 12 hours. So if this takes 12 hours, then to hit the maximum would be the double distance of that. This would be 24 hours, right? So I know my period is 24 hours. So finally, to find the frequency, this b value, we just go ahead and say b equals 2 pi over a 24-hour period. And just to show you once again how Desmos can be very helpful, if I go here and I type in 2 pi over 24, Desmos doesn't seem very helpful because I'm getting this really yucky decimal value. But if you take out the pi, Desmos will take care of simplifying your fraction for you, so it's 1/12. But if I put back the pi back in the numerator, this is 1 pi over 12, or pi over 12. So pi over 12 would be the b value. Pi, or since I'm writing in Canvas, I should write pi /12. All right, well, I hope that helped you look at some trigonometric modeling on the day 3 review.